In graph 3.3, we illustrated examples of intertemporal budget constraints, assuming that the two periods were 1 year apart. In this set of graphs, we'll extend the logic to n periods. Consider first a scenario under which you earn X dollars of income this summer, and you're planning ahead for a summer n years from now where you won't earn any income. We'll put dollars consumed this summer on the horizontal axis and dollars consumed n summers from now on the vertical axis. Your endowment bundle is the consumption bundle that has you neither borrowing nor saving, and since you're only earning income this summer, your endowment bundle is the bundle where you consume all X dollars this summer and nothing in the future. Now suppose you decide to consume nothing this summer, and instead you take all your X dollars of income and put them into a savings account. Suppose that savings account has an annual interest rate R, and it compounds annually. In that case, if you leave that money sitting in that account for n years, you'll have a balance of X times 1 plus R to the nth power when n years rolls around. Thus the most that you could consume n summers from now is X times 1 plus R to the nth power, assuming you consume nothing this summer. In other words, you could consume bundle B in your graph. Or you could do something in between, consume some of your X dollars and save the rest, ending up somewhere on the intertemporal budget constraint that connects points B and E in the graph. The slope of this intertemporal budget constraint is minus X times 1 plus R to the nth power divided by X, or just minus 1 plus R to the nth power. This implies that the opportunity cost of consuming $1 now is that you're giving up 1 plus R to the nth power in consumption n summers from now. Alternatively, we could assume that you earn no income this summer, but you know that you're going to earn Y dollars of income n summers from now. In that case, your endowment bundle would be the consumption bundle at which you consume Y dollars n summers from now and nothing this summer, because that's the bundle at which you have to neither borrow nor save. If the bank lends at an interest rate R, you could borrow Y divided by 1 plus R to the nth power and consume that much this summer. But if you do that, you're going to have to pay back Y divided by 1 plus R to the nth power times 1 plus R to the nth power n summers from now. In other words, you'll have to pay back Y dollars n summers from now, which is all that you're going to earn n summers from now. Thus, if you in fact borrow the amount Y divided by 1 plus R to the nth power and consume all of that this summer, you have nothing left over for consumption n summers from now. In other words, you'll consume at bundle A. And if you borrow less than that and have some left over for consumption n summers from now, you'll end up consuming somewhere along the intertemporal budget constraint that's formed by connecting E and A. Notice once again that the slope of this budget constraint is minus Y divided by 1 plus R to the nth power, which just comes out to be minus 1 plus R to the nth power, just as it did in panel A. It should make intuitive sense why the slope of the intertemporal budget constraint is the same regardless of whether we're borrowing or saving, assuming that savers and borrowers face the same interest rate. In both cases, this slope is the opportunity cost of consuming $1 now, in terms of how much we're giving up n periods from now. If we're in the savings scenario of panel A, then if I consume $1 now, I'm giving up not only that dollar, but also the interest I could have earned on that dollar over the n periods until n summers from now. If we're in the borrowing scenario from panel B, then if I consume $1 now, then I'm not just losing $1 of consumption n periods from now, I'm also losing all the interest that I'm going to have to pay for having consumed that $1 now, rather than waiting. In either case, the opportunity cost of consuming $1 now is that I'm giving up more than $1 in the future. More than $1 because I either could have earned interest or I'm going to have to pay interest because of that dollar's worth of consumption.